Let's add restriction on the dragging. So currently I'm doing a register stuff here, which let's add a lambda. The lambda gives me the new coordinates. As a point, I guess. Thinking I could pass it as a reference and then just make a change. Or I can return it. It kind of feels more natural to so a new pulse in and then a point out, and then normally you would just return it without any restrictions. Or yeah, okay, so draggable, register draggable point. I don't know. Point is, this point is not. No, I want to get a plot point, and then it's not that small, so maybe I should pass it as a reference. Also plot point out, of course. On the other hand, wait a minute. No, the lambda should not be bothered with the fact that it is a plot point. I just want to have x and y coordinates. So this is the plot point, which has also a mutable whatever. I'm going to use this one, which just has an x and a y. Can still pass it in as a const reference, I guess. I don't know. A double is 8 bytes. So yeah, I don't know. Pass 2 doubles or pass 1 a reference. Let's not waste time on it. So now I have a function that takes this as I hate abbreviations, so I don't know. Pos is kind of a normal one, but why would you do it? Position. Let's see, this is a window. This is the one that I want to change. So I'm going to add a standard function that returns a point and takes as argument a point const reference. Now we pass that in as a think by value. So stupid. No, I don't know. I don't know, man. Construction. I do have to store it. I think I have to store it. Yes, of course. This is just registration. Okay, let's pass it by value. And then I can move it. Who needs the restriction? Let me first finish this. So this thing, this being the header, register, declaration there. If I don't pass anything, then actually it should just be the default function, or maybe I should just not call it. I'm not sure if I can see if a standard function is default constructor. Suppose I can. Just a Boolean conversion. Okay. Anyways. Yeah, I still have to do that then, right? So if I don't pass anything, I can just default constructor. That would be the default. If you don't pass anything. And here we can just move it, I guess, to whoever needs it. That is the question. Grab point, update grabbed. I think this is where I need it. No, I need it here. Or not. No, this just finds the point under the mouse. And then when we drag it, this function is called. So we can just look at this function here. So we get new coordinates, and now we call update grabbed. Yeah. It is called update grabbed on the plot. That's the one that needs it. So the plot needs it then. Jump here. This is the one that needs it. Okay, go back. Yeah, the plot needs it, so I'm just moving it then here. Standard move restriction. I think a standard function has an allocation, doesn't it? Or not? I don't even know. Yeah, so optionally it did allocate something, so then moving makes sense. So you don't have to copy the allocation, you just move the pointer to the allocation. So then we have to do that as an extra parameter to the register draggable point of the plot. This is the one on the window. And then pass that as a R reference, because we moved it into it. And clickable restriction. Oops. Push back restriction. But yeah, I want to move it now as well here. Can you move into a vector? Or should I use an place back then? Maybe that should work at least. So the place back takes the constructor argument, so this will use the move constructor then. That should work. So I'll have to add this one, which is taking that as arguments. Well, this is, we are inside namespace plot now. So this is a plot point, but I don't want a plot point. I want a normal point. So I have to add cairo window. Right. So now the plot object has the restriction, which means that the update grabbed of the plot, which is here, can call it. So we're taking the mouse coordinates here in pixels, converted to the double values of the actual graph, and then we have to restrict it. So if clickable restrictions the correct point, that would be the one, exists, it's not empty, then we call it. Changing the coordinates, so now we no longer want to work with the XY. Now create point, it also takes a point. So this is a plot point. The create point takes a normal point, okay, a window point. So let's first put that in here. Let's call it just new point. Constructed from X and Y. And then we use that here. Well, let's call it new position. And here I just restrict the thing as in new position is, and then we call it so the new position is passed to the restriction function, and that gives me back other coordinates when it has to restrict it. This should already compile, I think. Why do I know? Just do that. Make. Totally not compiles. Doesn't even know what point is here, dude. That is really weird. I'll just include it. Wait a minute. The function is in the header function, isn't it? Functional. Heaps and heaps of errors. No matching function for call to construct add. In initialization, function template, specialization, candidate template ignored. I'm not interested. It's on the way where it came from. Requested here. That's what we need. But requested here. That's my thing. That's my file. So there is a problem here with the constructor of. We're trying to. I'm having a vector of a standard function of a Cairo window point. Should have added a functional here. Already got it from somewhere, but I don't know where I added the other one. Get div maybe. Having a functional in window.h. Oh, no. Should have another one. I added it before. Yeah, here. In plot.h and in window.h. They do not include each other. This one does not include plot. It's even for declaring it. And this is not including window, I guess. It's for declaring it. Yeah, so both needed then. Because you don't know which header being included first. But yeah, that does solve my compile problem. I got confused between the point and the plot point. I think the plot point here is not good. It should be just a point. Hi Seifel. How are you? Okay, where does my plot point come from here? Ars is that. It's the argument of my standard function. Of course, we are not interested in files like that. It must be this file then. The rest is STL. And then the type of the argument of restriction is wrong, apparently. Well, that would be this one then. So this is a plot point. Oh, your namespace plots. Oh, okay. Yeah, well. Cairo. Oh, this is plot.h. Yeah, of course. Cairo window. Right. No, that worked. I don't think that it's changed anything yet. Oop. Well, I also changed it that you can have them both at the top, as you can see, and at the bottom. So now it's working in both cases. If I do this, then it's still wrong. So one above, one positive y and the other one negative. Let me think. Yeah, I could add a restriction, I guess. What kind of restriction? How about you're not allowed to drag it outside of the plot area? So now I can just grab it and then, hey, you can go completely outside. This one too, on this side. Yeah, why not? I mean, if someone wants to drag it over here, let them be happy. Would be just to test that I can't go outside. So as a test, I could say, well, let's restrict it to staying inside this square here, so I can't go outside it. And then how? I think that I have to kind of detect in which quadrant we are in then. And then either go from here to there, or say from here up, or if you go here, then you just get stuck there. That seems the most logical thing to do. At the very least, I do need the coordinates of my, whatever this is called, plot area, I think. Oh yeah, it's just an XY independent clamp on the minimum max. Let's try that one. But it's actually not that easy, because I'm passing it from, say, the main function. No way that this the lambda just doesn't know anything about plot on I could capture plot here, but maybe I should pass plots to the lambda. Nah. Yeah, you just have to pass in stuff. Let's pass in pass by reference my plot. So now I have a plot, and then that will give me I'll just explicitly say that I'm only interested in plot. So now I can use plot by reference. So I don't know, it is a plot. Plot, what does plot give me? Plot gives me the plot area, yeah, but it's private, so can we access that? Loads of plot areas here. Construction. No. It does not have any. I think I should just add a function directly to a member function to plot that does the clamping. Boring but true. And that then is an, yeah, I don't care. So just let's add it. Clamp to plot area. There you go. So that returns a point and a cairo window point, and it takes a cairo window point. And it's pretty much const. constructed from this point. Standard. There's no clamp. Sure, there's a clamp. Standard clamp. Okay, I'll keep asking ChatGPT. Do we have a standard clamp? Clamp. Value low bound, upper bound. Great. So the value is then the points x coordinate and the x min and max. How do I find that? From set range maybe. It's a range, okay. A range x-axis. And the range is having a min and a max. Just use these two. And then the whole thing again for the y doesn't fit in the y just kidding. Okay, so yeah, that should work. Let's use it as well. Clamp to plot area is now existing in plots. So you can go back to here and then I can just do return plot dot clamp to plot area. And now we want to pass in the new position. No, whatever. If it compiles, you know. No, it compiles. So that means that it is going to work, right? So we can still move it around, but if now I want to go outside, ding, stuck there. Yeah, no, I know you're not allowed to go outside, dude. Well, pretty good. This, oh, that's the other point. We didn't climb that one. So VI and I have to pause that here as well. However, I wanted to have it. I wanted it to be the default. So if I don't do this, then it will be clamped to the plot area. Is that a good idea? So it is not doing it here either. Register draggable points. The window had this default thing. Could do there because we have to add a default. Register something. Yeah, okay, on one, yeah. So the default was doing nothing. Well, that's, yeah, okay. Oh, I just did it as a test. Yeah, so the default is nothing, and the test worked. Okay. So then, I want to have a point on the circle. This circle. That point is called, it has no name. This point here. I might as well add it to this maybe. Or then I have to add the dragging support and everything. Maybe just leave it alone. Let's call this point Q because I want to. I'm going to add a Q here though then. So people know that it's the same as in the previous program. No, find that back. I think it was P1R here actually. Yeah, totally. So just did not do that one. I want to use the little Q. Let's do center above. And let's rename P1R to Q. Hey, beam menu. aka Ninja. Q. Make. Run. There's a Q. I should really have directional vectors for placing the labels. No, it's straight above that point like that. It should of course be straight above in that direction or even in this direction. Put it there. This moving it up vertically is nonsensical, especially when you start rotating it. But well, that is Q. So let's add a point on the circle at some random angle and call it Q. Yeah, let's say I calculated from an angle. I don't think I have that angle, right? I just looked at it. No idea. I have to run it again. No. We have an alpha though. I could use alpha. I was thinking about this angle simply. But yeah, alpha would work. Alpha 0 then is inside P0 and then this is that's kind of weird though. If you make alpha larger than 180, sorry, larger than 90 degrees, then what? Now let's use this angle. Let's use this angle. So if that angle is 0, then we are in P0. Or is that nonsense? It doesn't matter. Do something. I need to think of a name as well. The name of the angle. I don't know. Let's use phi. Maybe, you know, it's kind of, yeah, I'm gonna use this angle. Not this one. So at an angle of 0, it's inside P1 then. We're going to call it phi. So not already a phi somewhere. Nope. Let's pick this phi to be a little bit larger than well, not 0 anyway. Let's say then pi divided by 10. So random. Okay. Plotted Q is plot create point. Second layer. Point style. Still need coordinates. What are the coordinates? Well, they are the center of the circle. Circle center plus the diameter of the circle is half, right? So 0.5 times the direction vector. And the direction vector can be constructed from the angle. Phi. That pretty much should work. think that should work. Looking for a label. Oh, there's a label here. Auto Q label is well, Q label style. I don't know where it normally ends up. C. Hello, Mr. S. Yeah. I called it plot queue. Make, plot, 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 plop, plop. And we have a queue at 1/10 of a pi. But it's not draggable. That's not interesting. So let's make it draggable by adding it here. Plot queue. And add a restriction. Oh, great. Now my comma key is also broken. It starts to get worse and worse. Well, you just start, really, just don't stare at the monitor, keep typing. Hello world seems like a good start. Have your program print hello world. That's where everyone starts. Although these days hello Mars maybe? Definitely going to need a plot. No, I don't need a plot. I'm going to need something, I don't know what. This was a point const reference. And then something close, yeah. Probably don't even have to say what the return type is. Kind of need to determine the angle and then use the same formula as here, I guess. So suppose, yeah, so put it there. No team, no, all alone. Sop. Return what? Return point. Out of names. Point. Okay. Yeah. Let's give it a return type. So this thing returns a point. And then I can just do constructed and only pass the coordinates here. Pass the constructor arguments of point. No, also that is nonsense because I'm not working with coordinates, I'm working with this. That's what we want to do. which then already is a point, I think. Direction times a half is a vector, I think. A point plus vector is again a point. So it, no, it already knows the return time. I learned myself, yeah. You realize I started in 1976, right? There was no internet. There was no internet for a long time. We just had a computer and with a keyboard and a monitor, and I thought, wow, that's interesting. Let's read a book. The book that explains how to code. That came with the computer, I think. Started in, it was called GFA Basic. Definitely we'll have to pass this one. That's the only thing. I'm not sure if we pass that by reference, so. I can pass by reference what is outside of the loop. I'm still outside of the loop, so if it exists I can pass it by reference. Right. Yeah, I'll just say explicitly that we are going to use that one by reference. Just because it is possible. And then here I need to recalculate my phi. And this time from. I don't really need to calculate a new phi. I just need the direction, man. You cannot calculate a direction. Bah, might as well do it here. So we're going to construct a direction from, I guess, the center, and it's just a direction. It's always from to, come on. So from there to the new position. That should work. If direction can be, yes, it can. I would have to blame myself if it was not possible. Directions can be constructed from 2 points. Ta-da! Problem solved. So this is a direction vector, which means it's a vector with a length of 1. Going from the center of the circle to where the mouse is. And now we multiply that by a half and add it to the center of the circle. Therefore, we are now on the edge of the circle, in the direction of where the mouse is. You will see it in a second. This was that one. Bleep. So, mouse, Q, drag. See, it stays on the circle in the direction where the mouse is. Isn't that beautiful? Oh. So the whole restriction stuff seems to work. I can also use this to make a slider. I want to make something, you know, rectangular with a thingy in it that you can grab and then move back and forward. But that must, of course, not go vertical then, only horizontal, and be clamped from the beginning to the end, depending on the size. So making a slider now should be very easy. But, Martin, hi, what am I doing? I'm coding-ish. Coding stuff. Oh, you see that? The queue is not moving along. It's, yeah, I have to move that into the loop. Queue label. So the queue is now, if I make the queue draggable, then the label must be drawn inside the loop, so it is updated. And so now the queue moves along, but yeah, so always stays on the left, on the left side. It's kind of weird, I think, but well, works for now. Okay, now I can do. Oh, I thought already. Now I want to do the other thing, namely draw lines from here to there and from here to there, and then everything else. It's just a lot of work. That's it. So this picture. These are dashed lines. There's an arrow here. So the direction vector, which is dashed, it's not a direction vector, directional vector from P0 to Q. Because it's signed, depending on the value V. Two directions. Okay, let's draw them. I don't know. Probably just code duplication. Be better. Well, in this picture I only have P0 and P1. Therefore you have freedoms, and one of the freedoms is where this Q is, as long as it's on the circle. And the other freedom is this theta. So I could make that draggable somehow. And then you can vary. Oh, there's another one even, I think. Wait a minute, that's not true. The theta is... It's complicated. But okay, let's say on one hand I can drag stuff, and on the other hand I can add the point where it has to go through, which then gives me the shape of the parabola, which means that I have these values. So either I go from SW in V to the position of Q, or I go from the position of Q to what SW and V are. And that the direction depends on how many points I have. So in this case I have 2 points. So I want to start with Q and then calculate these things and then draw the parabola. And in the case of this, I already have 4 points. So we first have the parabola, and then I have to calculate the position of Q that belongs to that. That's what I wanted to do. Let me just draw the lines. I remind you, yeah. We are making progress. It says, on one hand, it seems slow, but then you're not here one day, and you're like, "What? Is this the same program? Isn't it amazing?" I want to draw a connector. It's called. I'm having a lot of connectors there, but it's okay. From V to V1. Right. Let's do another one. X and Y. Yeah. These are also interesting, but not what we're doing right now. P0 to Q. Definitely what I want to draw. And that's a connector and a label. Oh, why not? So let's steal this code. Why am I sitting in the dark? It's so annoying that I can't see my keyboard. Because I'm too lazy to get up. Wait a minute. I'm getting up. Definitely should have gotten up earlier. No, let me see. Did I already copy it? No, if Q moves, then I suppose I have to do this inside this loop as well. This uses line style. Which is defined here as something with dashes. Maybe it's also defined here with dashes. Yay. Exactly the same. So good. So we go for the other one as well directly. So now I'm having the other one. The other one is something with SW. That's the label. Line from P1 to Q. Yeah. Niks zitten. Yeah, we don't have a P0. Why not? Probably because I called it plot P0. I have a plot P0. Oh, I deliberately removed the P0 because it's always at 0. Highly annoying, highly annoying, because I'm using it now. But okay, so I'm not even using plot P0 then? Wait a minute. I am line through, yeah, but I just added that. Or not. No, I didn't. Nah, yeah, no. Do I have a P1 or not? That is the question. I do have a P1. Great. Make. That's what I mean. I don't have an SW. Yeah, SW really is just a distance. Between P1 and plot Q. On the other hand, I probably want to have a variable SW. So this is where I have to make that decision. Either I work from SW to Q or the other way around. And I just started with adding a Q, so now I have a Q, and then from there I can calculate an SW. But I also need it the other way around, or need. I mean, that's how I'm going to get through the evening. You have to do something without a TV. I think I'm going for the length of something. And then I have to calculate a square root, but who cares? We have a length for a line piece, which can be calculated from 2 points. I have a length of a vector, which can be constructed from everything. And I have a length for a line. Well, it's also a draw line, not interesting. It's going to be either a line piece or a vector. Well, I'm not drawing it, so I think I should go for a vector then. How can I get a vector? Well, by allocating one, declaring it, defining it. And this vector is P1Q then. No, when I have a vector anyway, can I not create my connector from that. The create connector takes 2.2. Does not take a vector. Okay. Undeclared identifier perpendicular to symmetry line. QP1. QP1 is by definition perpendicular to the symmetry line. Apparently. Well, well, well. Now, draw it in. And it crashes. What happened? I lost my cue. That's weird. Oh, everything is gone. The curves, the whole curve is gone. But why? Can I not just drag it? I don't understand what went wrong. I cannot put Q below this point, below the line even. Yep, and gone. Now we even get a crash. What? Why is this not working? Which GDB? What? I don't have a GDB alias. That's why. Let's see. Copy this one wherever it came from. I hate copying, but well. Maybe it should have been a project. Not even sure if it will work then. If I add it here. Machine learning. Input source. which had alias. I don't have a .gdb in it. There is one in source. Let's see how general it is. Oh, it's a machine learning source. Yeah. Anyway. Do I want to use this one? It's a bit TensorFlow, a bit machine learning specific, I would say. Although this is all usable. Maybe we should test if there's one in the current directory, and then if so, use that, or just not use it if it does not exist. For now, I'll just remove it because I don't want to see the warning. Yeah. Exists. Yeah, it's grabbed my mouse. I can't move the window anymore because my application has grabbed my mouse. I can't even switch windows anymore, but I still have a keyboard, so press Alt Tab. Now we are in the debugger, but yeah, debugger is covered with a window. I'm just gonna kill it, I think. So I'll try this again, but now I'll move the window away. Then hopefully you can get a crash. Yup, Alt Tab, you have no mouse. Up. Stroke events, not a number. Connected to draw. Stroke events redraw. It's like it can't calculate the plot coordinate. That is weird. No, that is nonsense. I had no problem dragging Q around. This only happened after I tried to draw these lines, right? The connectors. Yeah. Something happens, but I don't know what. This is where I have no idea what's going on. I would say one of the threads isn't running, but they're printing stuff and everything. Yeah, I don't know. Let's try again to get some kind of crash or something. It does no longer want to crash. I'll comment out more. I think this code is all the new code that I added, and before that it worked. Cannot imagine that now it would not work after commenting out all of that. Yes, so now I can just rotate it everywhere. That's not a problem at all. This still works. Now, which of these is the problem? Let's add just the connector. I have a vector pointing. Definitely go that way. Oh, I just lost it. My mouse. Let go of the button, so we can do this as well. No, you cannot do that. A vector with a length of 0. That's a problem. It didn't have a direction anymore. Or no length. Ah, yeah, that's a problem. The length becomes 0, so the direction vector disappears or becomes not a number. And therefore things go wrong. Strange. Let me add a vector first then. Call that Q P0, and because I'm calling this one QP1 from plot Q to P0, and then I have to make an plot object first, I think. Yeah. This is a connector, right? It's a plot connector. So I first constructed like that. And then I have another function called add. And then I do not pass the constructors, but the thing that was constructed. And then we only do that if the length of this thing is not 0, so larger than or 1e minus 6, whatever. Not adding it means we don't draw it at all. But it can still show the level, I think. I want my arrow to point towards P0, so I really need a Q. Wait a minute. Never mind, I just deleted that again. Yep, that's okay. From P0 to Q. Not sure if my connector has a length though. But assuming it has, then this should work, and the label is using just a position, a recalculated vector. It's not a direction involved or anything. This then, the connector, does it have a length? Yes, because it is derived from a line piece. So that worked. Problem was just that the length of that vector became 0. If I make it really 0, and that's all impossible, you'd say. And still it happened. Because I mean, the label should disappear, shouldn't it? No, wait, I'm always drawing the label. No. Yeah, the arrow disappeared, sorry. Just the connector, so the arrow with the arrowhead here. That is not being drawn when the length is less than 1/1,000,000th. So that means that the arrowhead is still visible, the arrowhead. You can see that even if the length is almost 0, see? It even drops down. Now you see here, there's 2 lines, that's the arrowhead. So what I can do is make it 0 enough, and then the arrowhead should disappear completely. Yeah, oh, in this case. So now there's no arrowhead, so it's not being drawn, which means that the length is less than 1/1,000,000th. And we're not crashing, yay. Well, that's good enough, right? Now I can add the other one back, and that has the same problem, of course, that the length becomes 0 when I pass that point. Right, well, this is no fun. I don't want to have to do this. I just want to be able to do that without testing. Meaning that we have to go into the connector itself and see why it is a problem. What is this thing doing? The coordinates of the begin and the end. Create a draw object, and then we draw it. We draw the arrowheads. I guess the problem occurs when the well, not here anyway. field is none without an underscore. What? These are pixel coordinates. Yeah, that might be the place. That's nonsense. I mean, and not absolute value is less than that, and value of that is less than that. No. Unexpected. Should not layer. Well, this is 0. Yeah, that's a bigger problem. The layer region is empty. Really? Oh, the arrowhead too. That's weird. That is weird. Oh, right. Yeah, I'm getting it. I just should set the type then to 0. No, I cannot do that. Yeah, I can do that actually. I have to consider these things to be static. Okay. So let's draw connect. It's a bit problematic to get the direction then from this vector, because it can become something with a length of 0. Hello, Devon. What shall I do here? So at the moment that this length is 0, I can't calculate the direction, but I don't have to, because 0 times something is 0. It's a bit involved. Nah, this is nonsense. I should be able to get the symmetry line direction, even if Q equals P1, shouldn't I? I'll finish this though, but no, that works. Oh, I don't have a label anymore. Or I never had one. So it does not work. Yeah, right, it's not smart. Allocating it in this scope, so it's destroyed immediately. I just need a point word droid to point label position. The whole direction stuff is just nonsense. Why would I even do that? I don't need a direction at all. I just want to sit halfway Q and P1. So this is a much better way. Just divide the vector times divide the vector by a half. Length times direction. Yeah, duh. Which idiot wrote that? It's much better. And then there is no need anymore for special treatments. Can do that here as well. What? I don't even need a length anymore. So now we have an SW here, and yeah, moves along. Okay. Yeah, those labels are nice. Would be nicer if I actually had the values of SW and V, which are 3 variables, while I'm just changing one thing. So the only way to get the other 2 is by adding 2 sliders, I think, which I can freely change. And then this is one slider that goes in a circle, and then we have 2 other sliders that determine the other 2. And then we have an arbitrary parabola that goes through 2 points. Or, like I said, I can calculate these values from these 2 points. And then draw Q wherever it should sit. Let's see, for example, if we move this thing like that, then I think Q must be perpendicular to the symmetry line, or the symmetry line is now like this. So we put this one like so. Probably the right place. Maybe I should start with drawing in the vertex. This one here, so the vertex is like here. So in this case it should be here. Yep, now lots of work and I'm getting hungry. I'm going to eat something. I could let the stream stream for 5 minutes because I'm just going to make some soup, I think. Or oh no, I have to cook. Yeah. I'll be back in half an hour maybe then. And I'm also going to watch a movie after that, I think, maybe. So I don't know, hour and a half. Thank you for keeping me company.